Okay, so now we come down to dealing with these little average calculations that we've got here. I've put them in for you in the template for the very reason that the senior syllabus doesn't require you to actually know how to put them into an Excel spreadsheet, how to make it calculated. However, it does require you to know how to interpret it, and that is the important bit here. So, average you already know, okay, the average of both your columns. Number of trials. Well, we had 10 trials in each group. Okay, easy to see. Then we've got things like standard deviation coming up. Now, I'm not going to go into that in detail. There's other videos you can watch that really go into what that means in detail, but basically it is a measure of the spread of the data. So how widely these numbers spread, their range. It's not telling you that it ranges from 6 to 15. That number there is actually, it grabs the middle 65% of your data. That's how far either side of the average, the middle 65% fall. Plus or minus 3.8, either side of that number is 65% of your data. That's all you need to know for standard deviation for now. So this says that in this trial here with the 21 degrees, 65% of our data was plus or minus 0.5 from our average. Okay, and anyone who knows their math will go, hang on, but our average was 0.4 and minus 0.5 takes it to under 0. That is correct. Basically, it's saying that you have a very big spread, even though that's a small number, you actually have a very big spread that's got some error in it. And here, this actually tells us that our data is plus or minus 3.8 from 9.1. So again, it's quite spread out. In other words, we didn't have a great standard deviation. We didn't have a great spread in our data. There was a lot of error in it. So let's see if we can go into that in a little bit more detail. This standard error number here, that doesn't make too much sense until you put it into a graph, but basically it allows you to again compare how much error you had between the two groups. This group here had less error than this group here. In fact, this group here had like 10 times the amount of error as this group here. So it was a lot worse, which you can sort of see when you look at it that way. Okay. Confidence interval, we're not going to go into too much depth yet, so just leave that for now. So basically this tells us this. Here's all our data. There is more spread in the 35 degree one than in the 21. There is more error in the 35 degree one than the 21 degree one. A lot more error. Okay? But it still allows us to look for a trend or a pattern. Was there a effect? Did temperature affect the rate of growth, the respiration? Can you see a specific difference? Now, you can pretty much look at that right now and say, yes, temperature did affect it, because can you see a distinct difference between the two groups? Yes, you can. Okay? Can you see a distinct difference between the average? Yes, you can. Can you say conclusively that there is a really good reliability in this data? In other words, reliability means you can repeat it and get the same answer each time. No, you can't, because you've got quite a lot of range or error here. In other words, it's not really reliable data, but you can draw a conclusion from it. And that's what you're going to be writing up about. Okay? Now, before we go on and do any interpretation and writing up on this, we're actually going to graph this data as well. So now we've talked about that, we're going to go and see what this looks like in a graph. So the things that we actually need to graph are our independent variable groups, the the different groups that describe what different circumstances each of our tests were in. And what are they? That is none other than the actual temperature here. So I'm going to highlight that just so you can think. So our independent variable groups, that's the first thing we want to graph, because we need to know what it was at 21 degrees, what sort of growth it was at 21 degrees, and what sort of growth it had at 35 degrees. Then you're going to want to compare that not to each one of these little individual trials here, but you're going to want to compare it to the average of each of those trials, because that really tells the story of all of these when you look at them in combination. So you want to compare your independent variable groups to the average value for each of them. So at 21 degrees we had an average of 0.4. At 35 degrees we had an average of 9.1. That tells the story. As the temperature increased, did our respiration increase? Yes, it did. That's the story you're wanting to tell. But it's not the full story. You also want to have an indication on your graph as to the spread of that data, okay? And that's where our standard deviation and all of these other ones come into it. I would normally at this stage show you how to put this into a graph, and if you want to, you're quite welcome to. But for now I want us just to focus on interpreting it. So if you zoom over to the side here, where is it? Oh, there is what I did earlier. Phew, thought I'd lost it. Okay, now we've got two versions of this graph here. One that's a line one and one that's a column graph. The column graph is more appropriate here because it's two different groups that we're comparing, not one thing changing over time. So I want you to pull this graph over here and I want you to drag it down and make it nice and big. And you'll see this is what you've got first. The next thing I need you to do is improve these titles and stuff. The title is supposed to tell us what are we comparing, the two different groups. And we've already figured this out, okay? Your chart title here is going to be exactly what we put over here. I'm just going to highlight this, temperature, effect on respiration, copy that. Oops, go over here. And go, where's my chart design? I accidentally deleted my title there, but hopefully you won't do that. I'm just going to put it back and paste. Temperature effect on respiration, there's my title. On my y-axis, that is what we are measuring and comparing between the two. What's that going to be? What were we measuring? We were measuring the respiration in bubbles per minute. Again, you can just come over here, double click and then highlight it, go Command Copy, come over here to the axis title, double click so that it highlights it, and delete all of that, and go Command V for paste, and I'll put it in. Same down here with your axis title. Okay, this is our temperature in degrees Celsius. Double click, highlight it all, Command C, then come down over here, and where it says axis title you double click, and you need to delete all of that and paste that in. Command V, paste. Oops, I keep pressing enter. Just get out of that and you've got it. If that comes up here, just put the cross in there and ignore it. Now you've got a graph that you can actually do some writing about. Okay? Temperature, effect on respiration. Tell me, does this now tell a story? Does that picture give you something to talk about? Does temperature affect respiration? Yes or no? How much does temperature affect respiration? Well, look at how much difference we actually had there. Okay? There was a significant difference when you actually look at the effect of temperature and respiration. It was higher, but you might notice, as we already pointed out, that there's a lot of error in that data because there's a very big range, a very big deviation from the average for each one of these groups. Okay, it might only seem pretty small down here compared to this, but we were already dealing with really small average to begin with. So even a small deviation from the average is a pretty big error because it's such a small number. And this over here tells that picture as well. This here is what we call an error bar. And it is a measure of how much error is in our data compared to the average. Now the first thing I can see with this error bar is that one is a lot bigger than that one. So there's more error in this group's measurements here compared to this group. But we can still say that these guys are what we call significantly different. So when we talk about something being significantly different, it means that the change that we made between these two groups, 21 degrees, 35 degrees, did it make a definite significant difference to the number of bubbles per minute? Now your automatic answer would be yes it did, because this one is bigger than the other. Well, that just tells me there is a difference. A significant difference is more important and quite different. A significant difference is when there is no overlap between these two lots of error bars here. If there was an overlap of these bars, that means that essentially these groups had similar answers, at least for some of the time. Like they actually overlapped in their answers a lot. If those bars overlap, you have overlapping answers, which means we would actually write there is no significant difference because the error bars overlap. But in this case, our error bars do not overlap. So if I had to draw on this, here's the bottom of this error bar here, and here's the top of this error bar here. There is a really decent difference between the two groups. They do not overlap. In fact, they are actually miles apart. So we can say there is a significant difference between these two groups. Temperature did have an effect on respiration. Okay? Because there is no overlapping of the error bars, and there's a large distance between the top of one error bar and the bottom of the next. So that interpretation then forms what you're going to be talking about when it comes to how we write up about this data, which is the last bit of this video. Okay, so I want you to get to this stage first, and then in the next lesson, not today's lesson, but in the next lesson we're actually going to be writing up about this data as well. So what you're going to be asked to do is you're actually going to be asked to take this and submit it to me on Gateway so that I can have a look at how you went putting in this data into your table, putting it into a graph like this, and see how well you actually did doing your titles and everything else on your data like this. Okay, and submit that to Gateway, and we can have a look at that in preparation for next lesson.